Imagine a world where you can ask your database a complex question in plain English or Chinese and get back a perfectly accurate answer, no coding required. That's the promise of NL2SQL, natural language to SQL. But when the questions get tricky, requiring arithmetic, hypothetical reasoning, or common sense inference, most systems fall apart. Enter OraPlan-SQL, our system that ranked first in the 2025 Archer NL2SQL Evaluation Challenge, a bilingual benchmark designed to test exactly these kinds of complex reasoning skills. We achieved 55% execution accuracy in English and 56.7% in Chinese, outperforming the second-place team by over 6 percentage points, all while maintaining over 99% SQL validity, meaning nearly every generated query was syntactically correct and executable. How did we do it? Not with a sprawling multi-agent pipeline. Not with brute force model scaling. Instead, we built a lean, elegant framework centered on planning, and we made that planner smarter through a novel feedback-driven refinement technique we call meta-prompting. Let's break it down. At its core, OraPlan-SQL follows a two-agent architecture, a planner agent that converts your natural language question into a step-by-step natural language plan, and a SQL agent that turns that plan into executable SQL. The beauty is this: the SQL agent is highly reliable. It faithfully follows the plan. So if the system fails, it's almost always because the plan was wrong. That means the real challenge isn't generating SQL, it's generating correct reasoning steps. Prior approaches either tried to do everything in one shot, leading to hallucinated joins and broken arithmetic, or used multiple specialized agents. But those multi-agent systems suffer from orchestration overhead, fragile handoffs, and error propagation. They're like a team of specialists who can't agree on the playbook. We took a different path. Instead of adding more agents, we refined a single planner, using real failure data, human insight, and a language model to distill corrective guidelines. Here's how it worked. We collected a set of queries that our planner got wrong, queries involving hypotheticals, arithmetic, or counterfactual reasoning. Then we had human experts label and cluster these errors. Was it a timing mistake? A misinterpreted condition? A flawed aggregation? Then we fed those clustered failure patterns into a large language model, not to generate answers, but to generate guidelines. The LLM analyzed the patterns and distilled them into clear, actionable rules. When the question says if, first state the assumption as a filter, then define the action. Or for percentages, always write, percentage equals 100 part/total. These guidelines weren't just slapped onto the system. They were integrated directly into the planner's system prompt. This is what we call feedback-guided meta-prompting, using real-world failures and human judgment to evolve the instructions the planner follows, not just its outputs. The result? A planner that learns from its mistakes, not just in training but in deployment. And it generalizes, even to unseen reasoning types. But here's where it gets even more interesting: the bilingual challenge. In Chinese, proper nouns often don't match database entries due to transliteration issues. For example, Glebe Park might appear in the query as Chinese letter, Chinese letter, Chinese letter, Chinese letter, but the database entry could be Glebe Park or Glebe Park. A direct match fails. So we added entity linking guidelines to the planner's prompt. Now, whenever the planner encounters a named entity, like a stadium or person, it's instructed to generate alternative surface forms before writing the plan. For Balmore, it might consider Balmore Stadium, Balmore Park. For New York, it might generate NYC, New York City, NY. These variants are then explicitly included in the plan, so the SQL agent knows exactly what to look for. No more mismatches. No more failed joins. And to further boost reliability, we introduced plan diversification. Instead of generating just one plan, we set the planner's temperature to 0.7, encouraging multiple plausible interpretations of the same question. Each plan is passed to the SQL agent, which generates a corresponding SQL query. Then we run all of them and select the final answer via majority, voting over their execution results. If 3 out of 5 plans agree on the answer, we go with that. If one plan is wildly off, it gets drowned out. This simple trick dramatically increases robustness, especially in ambiguous or complex cases. Now let's talk results. On the Archer test set, OraPlan-SQL achieved 54.96% execution accuracy in English, beating the runner-up by 6.3 points. In Chinese, we jumped from 44.08% to 56.67%, closing the cross-lingual gap that plagues most systems. Ablation studies confirmed why each component matters. Removing the meta-prompting guidelines dropped accuracy from 72.12% to 44.23% in English. Removing the planner entirely, down to 64.42%. Even without majority voting, we still saw a small but meaningful boost, just 0.97 points, but it's the consistency that counts. And the best part? This framework works across models. Even with GPT-4o, we outperformed the second-place team. But with GPT-5, we hit 72.12% in English and 79.81% in Chinese, a testament to how much the design of the prompt and reasoning pipeline can amplify model capability. So what's the takeaway? In complex, real-world NL2SQL tasks, especially bilingual, reasoning-heavy ones, the key isn't just a bigger model. It's better reasoning design. By treating the planner as a reasoning engine, refining it with real feedback, embedding multilingual robustness directly into the plan, and using diversity to vote on correctness, we've built a system that's not only state-of-the-art, but scalable, interpretable, and efficient. OraPlan-SQL isn't just about generating SQL. It's about generating correct thought. And in the age of AI, that's the real breakthrough.